lecture. Parity means equality. So in this lecture, we look at a relationship or equality between interest rates of two countries and their foreign currency rates over time. It turns out that this relationship is one of the most trustworthy relationships about foreign currency prices. That is, we can use it to judge if a foreign currency would get cheaper or more expensive against our currency. Interest rate parity, which we also call as IRP for abbreviation. The nice thing about this parity is that you could say it with words and with an equation, and both of them are as meaningful. In fact, one of my biases is if a teacher writes an equation on the board and he or she is not able to discuss that equation fully in words, then that person does not know the meaning of that equation. So let me take that challenge and discuss the equation fully in words. The left hand of the equation says the forward premium or discount. Let's first focus on this word forward. In our last lecture, we talked about forward prices versus spot prices, and we had an example from ancient Greece. That example said that the forward price is how much one pays for olives at the harvest time 6 months from now, or for my laptop in June 1st. So we make a contract and we pay for it in the future. We also had a spot or cash price, which said how much you would pay right now to purchase my laptop. So we know what the forward price is. That's the price in the future. Now we focus on this word forward premium or discount. Well, we discussed that the forward price might be more than the spot price. We call that a premium. And look at the tie that I'm wearing. Well, you can see it in this slide. If I paid more for it and it was a premium product, then the price is more than regular price. So the word premium here means that this forward price is more than a spot price. You're paying 250 euros to have the laptop June 1st, but right now you're paying 200 euros for it. And of course, we discussed that this price difference could be because of demand and supply differences over time. There are fewer people who may show up to buy later, and there might be fewer suppliers. And this may affect the price. Price is driven by demand and supply in a competitive market. And this word discount, of course, means the opposite. In June 1st, you would pay 150 euros if you buy my computer there, if you make a forward contract to purchase it there. But right now, you pay 200. So you pay less money in the future. And of course, if my tie was a discount tie, it means that I paid less for it. Okay, so the exam would ask you, what is forward premium? You say the forward price is more than the spot price. And sometimes I give you these two prices. And the forward price is 200, the spot price is 150, and I would ask you if we have a forward premium or discount. you would say, well, the spot price of 150 is less than the forward price of 200. Therefore, we have a forward premium. The forward is worth more money. And if the forward price was 150 and the spot price was 200, you say the forward price of 150 is less than the spot price of 200. Therefore, we have a forward discount. So both situations can happen in reality. And of course, we can have a forward parity. The price is 200 now, and the price to purchase it June 1st is also 200. Okay, so that's the left-hand side of our equation. Notice how we write it as a formula. F, which stands for forward price, for example, 200 euros, divided by S, the letter S stands for the spot price, 150. And if F is more than S, this becomes more than 1, and then we would have a forward premium. And if F is smaller than S, and this ratio becomes less than 1, and we have a forward discount. So another way that you can judge forward premium or discount is from this ratio of F divided by S. And if you have forward parity, F divided by S obviously would equal 1. Okay, now we get to the equality sign, and you see the equality sign here too. On the right-hand side of the equation, we have a ratio. In words, this is called ratio of nominal interest rates, or here it says interest returns. I promise you to focus on every word, so let's do that. First, this word nominal. The word nominal is opposed to the word real. So you have nominal interest rates and real interest rates. Nominal means the quoted interest rate. We ask how much is the cost of capital on this debt, interest rate on the loan, and they say 4%. That's a quoted interest rate or a nominal interest rate. Real interest rate is when we adjust this 4% for inflation. Imagine that inflation is 1%. We write 4 minus 1 equal 3%, and we say real interest rates are 3%. That talks about purchasing power that your money would have after you get 3% more, because inflation is 1% and prices will go up by 1%, but your money in the future would buy 3% more. Your money increases by 4%, but prices increase by 1%, so you have 3% more purchasing power. It is also worthwhile to mention that although this 4 minus 1 equal 3%, nominal interest rates minus inflation equal real interest rate is an equation that is done in practice, and I just did it for you. But this calculation is wishy-washy. We use wishy-washy in English, and we use wishy-washy in German, and perhaps in German it's more funny. But anyways, beside that joke, this equation is not precise. If we want to have a precise adjustment and calculate the real interest rates, we have to look at rate of returns. And we have to discount by inflation rate. How do we discount? Well, we learned that in our first finance class, or you would learn it if you have that course. We divide by 1 plus interest rate. And to compound your money, if you have 100 euros and you get um, 4% interest, you would multiply it by 1.04. If you want to compound it by real interest rates, you take this 100 and multiply it by 1.03 to get 3% more interest, and then you multiply it by 1.01 to adjust it for a rate of inflation. So if we want to correctly um, calculate this real interest rates, we say 1 plus okay, this doesn't write very well, so I pause it and find a different way of doing it. All right, I made us a new slide that talks about real and nominal rates. The exact formula is 1 plus nominal interest rate, for example, the quoted interest rate of 4% for our loan, equals 1 plus real interest rate, how much our money would buy after inflation, given this increase in prices, multiplied by 1 plus inflation rate. And of course, you can divide both sides by 1 plus inflation rates, and you get a formula for calculating real interest rate. 1 plus real interest rate, or this x unknown, then would equal to taking the nominal interest rate of 4%, adding it to 1, writing it as 1.04, and then dividing it by 1.01 for inflation rate of 1%. And then you get an answer that has an extra 1. You subtract 1 from it and you get real interest rates. But the approximate equation, which is not the true formula but gives us an answer very close, so quite a few people, even professors, use it. Nominal interest rate of 4% equal real interest rate of 3% plus inflation rate of 1%. And of course, if you want real interest rates, you say 4% minus inflation rate of 1%, and you get the answer equal 3%. In fact, it's a good exercise for you at this point to put a nominal interest rate of 4% here, write this as 1.04, and write this as is, as an unknown, an x, and here write as 1.01. And then solve this equation for real interest rate and see how much is your answer different from 3%. Then you would see that the approximation is not so bad. Let's go back a slide to where we were in our discussions. We were talking about forward premium or discount, and we got to this word nominal interest rates, this word nominal interest return, I would say, and I explained what nominal interest was. The word nominal comes from naming it. It's the bank names or quotes the interest rate to you. And these are the interest rates that you hear in real markets. And real interest rates are not the interest rates that you hear in real markets. So this is a little bit funny too. The real interest rates are really imaginary, something that a professor or some analyst sits in the back office and calculates, and you don't see in daily trade. But the nominal interest rates are the real numbers that you see coded as the interest of a loan or cost of debt capital. All right, then we focus on this word return. The word return means how much money you get back. So usually if we have 100 euros and we invested at 4% interest, after a year we would get our 100 euros back. Therefore we multiply it by 1, and then we get 4% more as interest. Therefore we multiply it by 0.04. So if you multiply by 1 plus interest rate, you would get your return, and that 1 in the equation is to give you your money back. You get your 100 back, you multiply it by 1. And the interest rate is to get a percentage more as cost of debt capital. So the right hand side of equation, after equality, we got to the right hand side of equation, says the ratio. So we are dividing two things. We are talking about this division of nominal interest returns of two countries. So this is one country and its return, because it has 1 plus their interest rate, and we denote their interest rate by capital R with a subscript F, F for foreign. So this is the nominal interest rate in the foreign country. Notice that in economic and finance, sometimes we use capital R's, sometimes lower letter R, and sometimes I for interest. Of course, this is just a matter of notation, and it shouldn't confuse you. And we're dividing by the nominal return. So we have 1 to make a return, and then we have the interest rate, R, of the domestic country, D. These notations are also defined in the slide for you, so you can trace them back later as you look at this video. For example, F is defined as forward exchange rate. Let's do example of the two countries, Japan and US. This would be how many yens per dollar. For example, 117 yen per dollar is the price we pay in yen to purchase dollars forward, for example, 6 months from now. Then you go to S, which is the spot exchange rate. It's a different price, so we indicate it by a different letter, and that's how much you pay right now to get yen, to give your yens and get dollar. For example, you pay 120 yen and get a dollar. RF is the nominal, and you and I talked about this nominal. This is the coded interest rate, and does have inflation in it in the foreign country. And RD is the nominal interest rate in the domestic country. Now the question is, who is foreign and who is domestic? If you and I are doing this and sitting in Germany, Germany does not necessarily become domestic. Euro does not become domestic in the formula. Same here with yen and dollar. If you're sitting in US, necessarily dollar is not the domestic currency. In this equation, we know the domestic currency by looking at the denominator. So the currency that you would receive 1 unit of it for certain number of units of the other currency, yen. Here, for example, 117 yen gives you $1. Then dollar is domestic, and yen or Japan is foreign. So here for RF we put the interest rate of Japan, and for RD we put the interest rate of US. If they gave us these quotations different, and sometime I do that in the exam, I would give you the foreign exchange rate dollar per yen. For example, 1 cent, 1 American cent per 1 yen. Let's make it a little different from 1 cent. For example, 1.1 cent per yen. Then, because you're dividing by yen, it's per 1 yen. Japan becomes domestic and US becomes foreign. And of course, both rates are coded that way then. Alright, let me review what we learned so far. We learned about forward premium or discount. And that concept is reviewed in this slide. It says if it takes more yen to buy a dollar in the forward market than the spot market, then the dollar is at a forward premium with respect to yen. In other words, dollar is more expensive if you buy it in the future than it is right now. And of course, in math, we can write it as we discussed before in terms of F and S. F, which stood for forward price, is more than S, which stood for a spot price. Or if we like to write it as a ratio, we say F divided by S is greater than 1, therefore we have a forward premium. For the equation that we just saw, we need certain conditions so that this equation holds. Those conditions are as follows. Number one, maturity matching. Maturity matching means that all the financial instruments that we have in these two equations have to have the same maturity. So the first thing we got to do is define this maturity for a loan. When does a loan mature? It basically means when do we have to pay the principal of the loan back. If you borrow €1,000,000 for your company, €1,000,000 is called the principal of that loan, and you pay interest on that loan. If you borrow for 10 years, after 10 years, you pay the €1,000,000 back. You're paying the principal back. 10 years is the maturity of that loan. Every year, you pay interest on that loan. Okay, maturity matching. That means the forward contract and the domestic and foreign bonds used for interest rate codes must have the same maturity. Here, I'm going back to our interest rate parity formula, and you see that we are using F as a forward contract here. And the time on this is 6 months from now. Then this interest should come for a 6-month loan in the foreign country Japan, and this interest should come for a 6-month interest in US. That right away tells you that 6 months interest rates are different. Okay, we were talking about maturity matching, and in this maturity matching, we talked about bonds. So it's good for you and I to define bonds precisely right now. I guess the joke is bonds are things that bonds people together. A good definition of bonds has two elements in the definition. The first element says that bonds are debt, borrowing. So a corporation that issues bonds borrows money. The second element that one should say in a definition of bonds, for example, in my exam, is that bonds are liquid. Liquid has a different definition in economics than the liquid that you're used to in everyday life. Water is liquid. But here, by liquidity, we mean that you could sell these instruments, these financial instruments, at a fair price and quickly. The fair price part of the definition is important because you could always sell a non-liquid asset at a unfairly low price. We call it a fire sale. These fire sales also have a funny story that you might have heard. Um, Old Roman times, the fire department worked as follows. Your building would be on fire, and you would call the fire department. They would come and start negotiating with you to purchase the building from you. And of course, the more you wait and negotiate on the price and don't give them the price that they like, the more of the building burns and the more of the asset is gone. Therefore, a fire sale. The word went into our vocabulary. When you hear about Nero burning Rome, well, it wasn't exactly that he burned Rome. They gave him fake news. It was more that he had an interest, financial interest, in the fire department, and of course, the fire department was in the business of waiting until the buildings burned and then buying them. Okay, so we learned what liquidity is: an asset that can be sold quickly and at a fair price. Bonds are liquid, and to make them liquid, you need lots of them, um, and you need the fact that you have lots of them and they're identical allows people to trade them at all times. Then these financial instruments become liquid. Bonds are typically the same amount of borrowing. €1,000 is a very common value, so each bond is €1,000. You can loan €1,000 to Siemens. That's financial democracy. You do not have to be a multimillionaire to loan money to Siemens. But Siemens issues €1,000 bonds to raise €1,000,000. All these are contracts that says I owe you money, and different individuals purchase these loans. Means they give €1,000 to Siemens, and these loans are traded in the marketplace, and their price changes too, just like the price of stocks. They buy and sell every day. So if you loan €1,000 to Siemens and 2 days later you need your money, you can go and sell this loan to someone else. And they give you money back, but they don't give you €1,000 back. The price changes. It depends on maturity, it depends on the interest rates on that day, and bonds are a whole lecture by themselves. But you and I need a definition here. And that definition of bonds is that they are loans and they are liquid. So back to this sentence. We are talking about foreign bonds. And in parentheses, it says used for interest rate quotes. So if we want to figure out what the interest rates are in Japan, we go and look at Japanese government bonds. And if we want to know what the interest rates are in US, we go and look at US government bonds. And of course, government bonds means that US government borrows money from individuals. and pays interest on it. And these interests are different in different countries, and that speaks to the interest rate in that country. So this maturity matching says that these bonds should have the same maturity. The government bond for US is for 6 months, and the government bond for Japan should also have a maturity, or the loan should be given for 6 months. It can't be that you use 6 month bonds for one country and 2 year bonds for another country. This brings another important topic that you and I should know, and that's time structure of interest rates. It means that if you borrow for different maturities, for different number of months or years, you would pay different interest per year. Keep in mind that interest rates on bonds and practically everywhere else in finance and economics is coded to you as a real interest rate per year. I shouldn't use this word real, as a yearly interest rate. For example, they say the interest rate is 4% per year, even if you borrow for a month. But because you have borrowed for a month, you pay 1/12 of this 4% interest. And if you borrow for a year, the interest rate would not be exactly 4%. The yearly interest rates are different from monthly interest rates. The yearly interest rate might be 4.5%. So after a year, you give 4.5% back. So maturities matter because they affect the interest rates. Interest rates are different for different maturities. Therefore, we should have apple and apple comparison, not apple and orange comparison, by picking the same maturity for all bonds. Next condition for our formula to work is risk matching. When you go back to this formula, the risk of these bonds should be the same. You cannot use a riskier loan and compare it to a less risky loan, because with default risk, the interest rate on the loan goes up, um, and loans are often rated by credit agencies such as Moody's, S&P, and Fitch. They usually give similar ratings. Fitch is French, S&P and Moody's are American. And these rating agencies verbally tell you how much the risk on loans of governments and loans of major corporations is, and how this default risk changes over time. For example, AAA rating would be the highest rating um, that they may have, and that would say that the possibility of default is very little. If you go to their webpage, they verbally define what they mean. And when the company has more chance of bankruptcy, this rating goes down. For example, ThyssenKrupp had the rating going down because of investments that they made in Brazil, and these investments um, did not produce. They had environmental problems, and eventually they had to sell those factories, and therefore they had a higher uh, possibility of bankruptcy, less likely to pay their loans. So the rating dropped, for example, to single A. Okay, already we got a problem because the government of Japan doesn't have the same risk as the government of US. However, we have an idea of what these risks are, and we can adjust the interest rate. So I leave that as a sidebar issue, but we have to pay attention that the two interests of the two countries are from the similar loans. That's why we don't use corporate bonds, but we use government bonds, because in a sense they are better known and easier to do this risk matching. Finally, every input that we enter in this formula is uh, entered as a decimal. So 4% is not written as 4 with a percentage sign, but is written as 0.04. This is a very good practice in calculations in economic and finance. And the reason for it is if you write 4% and your equation um, multiplies 4% by 4%, for example, squares it, then you get 16, but it's not percent anymore, it's out of 10,000. And that gives us a headache. But if we leave it as 0.04, we will not get errors in calculation arising from that change in um, percentages to per 10,000 or something like that. Let me now move to an example. This example is from Harvard Business School lecture notes, and the numbers are made up to fit a good classroom pedagogical objective so you and I can understand it better. The numbers are not real, but of course you can work with real numbers later on, and as an exercise we may do that. And this example clarifies everything that we verbally and with equations discussed together so far. First of all, it says that 1 year Japanese bonds pay 4% interest. That means in equations or notation R sub f equals 0.04. In other words, if you loan 100 to Japanese government, after a year they pay you 104. And of course this loan has to be in yen, for example, 100 million yen. Number two, the 1 year, notice that these two 1 years have to be the same because of maturity matching. US Treasury notes. This word treasury also needs definition. Every country has its specific words for their government obligations or loans. Particularly the US words are important in international finance because international companies and individuals could participate in these markets and often do. So you and I, as employees of companies, may have to deal with US loans that our company had purchased. For US loans, we use this word treasury. And if we say treasury bond or T-bond or treasury bill or T-bill or treasury note or usually you don't say T-notes, I haven't heard that before. These three imply different maturities. Treasury bills are for maturities of less than a year. So if we are talking about loaning our money to US government for 2 months, it's a treasury bill. Treasury note are for maturities of more than 1 year up to 3 years. And treasury bonds are from 4 years or more. So in this case, it says a 1 year treasury note. 1 year is right at the border, so you could call it treasury bill or treasury note, and here we're calling it treasury note, pays 8% interest. RD equals 0.08. Notice that I write it as a decimal. Next, we have a spot exchange rate. S here, a spot exchange rate, is given to us as 120 yen per dollar. Notice that all these inputs to the equation are available from your Bloomberg terminal or from internet. These are the data that you can get and trade on. So the spot rate is 120 yen per dollar. This is given as Japanese yen per US dollar. Because it's for $1, then we know that dollar is domestic. So this RD that I wrote here wasn't something that I did because I was American, but it was something that I got from this equation. At this point, let me save this video as part 1 and give you part 2 later, as the size of the video might be too large.